Our next unit is a study of exponential functions, but it starts off with a review of the laws of exponents. These are the same rules, the same laws of exponents that you've done in Algebra 1, Algebra 2, Geometry. So hopefully this is a review, but if not, we'll go over them one more time. So they're pretty simple, pretty basic rules that I know you've been using this year, even probably without thinking about it. The first one is if you're multiplying two things together, then we're going to add the exponents. So, for example, if I had x to the third power times x to the fourth power, then I get x to the seventh power. When I'm multiplying, I add the exponents. And the same with dividing. When I divide, I subtract the exponents. So if I have x to the fifth power divided by x to the second power, I get x to the third power. When I divide, I subtract. Whenever I have an exponent raised to another exponential power, a power to a power, then I multiply. So this would be something like x to the third raised to the fourth gives me x to the 12th power. And then negative exponents. We usually try to get rid of negative exponents within a problem, and to do that, you just move it to the bottom. So for example, if I have x to the negative third power, that's equivalent to 1 over x to the third power. Now, in addition to that, if you have a negative exponent in the denominator already, so let's just say I had 2 over x to the negative third power, so that the negative was in the denominator, then to make that positive, I move it up to the top with the 2. And then there's nothing, just a 1 left on the bottom, or just 2x to the third. So to make a negative exponent that's in the numerator, to make that positive, it goes to the bottom. One that's already in the bottom as a negative exponent, you move it up to the top and it becomes positive. And then one that's not listed up here, but I'm going to add, is that anything to the 0 power, anything raised to the 0 power is 1. So add that to the list of rules up there at the top. All right, so we just have some examples here, and we'll run through them. If you're just talking about regular numbers, like in this problem, 3 times 4, you just use regular number rules. So 3 times 4 is 12. But as far as the a's go, a to the first times a to the third would be a to the fourth, because when you multiply, you add the exponents. For this problem number 2, we're just going to reduce our fraction just like we would with any fraction if it weren't attached to all those letters. And so these are divisible by 9. 9 will go into 27 3 times and into 45 5 times. So I get 3 over 5. And then for the letters, I have x to the third divided by x to the fourth, which gives me a to the third divided by a to the fourth, which gives me a to the negative 1 power. And b to the third, there aren't any other b's, would stay on the top. C to the fifth divided by c squared subtract, I get c to the third power. And then as we said, we're not going to leave negative exponents, so this negative exponent we can move to the bottom and make it positive. So I get 3 b to the third c to the third over 5 a to the first. Now there is a little bit of a shortcut on this type of a problem if you want to use it. For the most part, just remember it's top minus bottom, top minus bottom. That's how we got the negative 1 and the 3. But this negative 1 ended up going down to the bottom because the larger exponent was on the bottom. So if you wanted to just subtract and take the absolute value and put it where the larger exponent is, that works as well. So it would go straight to the bottom. But the rule, what you're actually doing is top exponent minus bottom exponent. All right, for number 3, everything inside these parentheses is raised to the third power, so I have negative 3 to the third power, and then I have x to the third power, and then I have y squared to the third power. Now I put that negative inside parentheses because remember that it does make a difference. If this had been negative 3 squared, it becomes positive, but it's negative 3 to the third power, and a negative times a negative times a negative is negative. So negative 27, x to the third, and then power to a power, I multiply, I get y to the sixth. All right. Number 4 actually helps explain this rule right here. So let's just talk about it for a minute. X to the n divided by x to the n means that I have a number divided by itself, and any number divided by itself equals 1. But also, using my rules, whenever I subtract here, I would have x to the n minus n, or x to the 0 power, which is also 1. But it's because if I divide two things that are the same, I get a 0 power, and when two things are the same and I divide them, I always get 1. So it kind of explains this rule up here. All right. So this next one, this is always confusing. Every year I have students who confuse this with multiplying just the numbers and doing something with the exponents. But remember that when we talked about multiplying up here, this b could be anything I want it to be. I chose for it to be a letter, but this b could as well have been a number. And the rule still applies because x represents a number as well. So what I'm telling you is that you don't multiply. I didn't multiply x times x. I multiplied and added the exponents. The b part, the x, stayed the same. So same is true here. I do not multiply the 5s. It's still just going to be 5 raised to, and then I add the exponents, the negative 8th power, or 1 over 5 to the 8th power. 5 to the 8th power is a really big number. If you want to multiply that out, you can. You might want to grab yourself a calculator, but there's 5 to the 8th power. All right, so with that in mind, number 6 is the same way. We are just going to use the exponent rules. These all have the same base of 2, so we're just going to, on the top, when you multiply, you add the exponent. So 8 plus negative 5 would be 3. And then I can move this negative exponent up to the top. And then when I multiply, I add the exponents, and I get 2 to the 7th power. And 2 to the 7th power is 128. Now, another way you could have done this problem is, instead of moving it to the top, moving the negative exponent to the top, I could have used my rules, and I know that whenever I'm dividing, I subtract. So I would have 3 minus negative 4, which would be 3 plus 4, which is also 2 to the 7th. So either way, I still get 2 to the 7th power. All right. For this next one, I need to distribute. So that means I'm multiplying this thing times all of those. So 2x y to the third times x cubed, the only ones that are going to change are going to be the x's. I would get 2x to the, when you multiply, you add, so 4th power, 1 plus 3 is 4th power, y to the third, minus, and then 2 times 4 would be 8, and then x to the first times x to the first would be x to the second, and y to the third times y to the second would be y to the fifth. You add the exponents, and then minus 2x to the first times the second would be the third, and y to the third times y to the third would be y to the sixth. And none of these can be combined because none of them have the same exponents. All right, so for number 8, we are adding these exponents. So I have a to the x plus 3 plus x minus 3 power. Well, the plus 3 and the minus 3 are gone, so I just get x plus x, which is 2x, a to the 2x power. This one is our rule that we stated up above. Anything to the 0 power is 1. And for number 10, power to a power, you multiply a negative times a negative is a positive. So I get positive 4 to the positive third power. And 4 times 4 times 4 is 64. So this exercise is just on practicing using these rules for exponents. Hopefully this is a review for you guys. And the homework assignment is kind of a little puzzle instead of a regular worksheet.